Boa noite a todos. É um prazer estarmos hoje aqui reunidos para mais um webinar organizado pela ABMS, né? O de hoje é organizado pelos editores da revista Solids and Rocks, professor Renato Cunha, da UNB, e o professor Gilson Gitirana, da Universidade Federal de Goiás. A Solids and Rocks é um periódico internacional das associações brasileira e portuguesa de geotecnia, ABMS-SPG, e já foi iniciado há quase 50 anos. E foi com grande esforço de ambas as instituições, as associações, e também com o trabalho incansável dos editores, do grupo de trabalho por eles coordenado, né, que a revista vem sendo a cada vez mais, né, tendo destaque cada vez mais crescente. A ABMS é uma organização já de grande tradição, né, aqui em geotecnia, completou recentemente 75 anos desde seu início, né, e ela organiza sempre muitos eventos na área de geotecnia. Este ano, eu gostaria até de convidar a todos, né, teremos em breve o Geonorte, em abril, em Belém, vai acontecer em Belém, o nosso grande evento, o Cobranzeg, que esse ano vai ser realizado em Brasília, em agosto, e o Geo Carioca em novembro, aqui no Rio de Janeiro. Hoje nós temos o imenso prazer de receber o professor Poulos, que é um grande consultor internacional na área de fundações, que já nos brindou em algumas ocasiões com palestras em eventos aqui da BMS, né? E também nos prestigiou com publicação de artigo na nossa revista Soils and Rocks. Eu gostaria, então, de dar as boas-vindas a todos os presentes, desejar um excelente evento e passo agora a palavra ao nosso editor, professor Gilson Gitirana.
Boa noite. Obrigado, Bernadette. Então, foi aqui me solicitado, né, dentro do nosso planejamento, que a gente desse uma pequena palavra, muito curta mesmo, coisa de uns 5 minutos, apenas informando e transmitindo para o público, para os associados da BMS, para o público em geral, algumas novidades sobre a Soils and Rocks, como é que tem evoluído o processo editorial da revista, os índices. Então, a minha fala vai ser muito breve sobre esse assunto, e em seguida a gente dá início, né, passando a palavra para o professor Renato e para o professor Poulos. Então, pode colocar os slides na tela, por favor. Então, a primeira coisa é relembrar a todos, né, qual é a nossa missão dentro da Soils and Rocks como a revista, né, internacional da BMS e da SPG. Né? A Soils and Rocks é o nosso veículo de publicação de artigos de excelência, né? Artigos de qualidade e que têm importância dentro da geotecnia. A Soils and Rocks ela tem como princípio a publicação de artigos com acesso livre, então é uma revista open access, sem taxas, né, de publicação. Nós temos também como meta ter um sistema de revisão muito criterioso, mais ou menos um tempo ágil. Então, eu vou falar um pouco sobre estatísticas de tempo desde a submissão até a resposta à decisão, baseado nos pareceres. A revista é uma revista indexada nos principais mecanismos, né, de indexação, tem buscado publicar artigos de qualidade e, como consequência, né, ter uma elevação no fator de impacto da revista e no Qualis, claro. Né, e um outro princípio da revista é ter sistemas muito bem organizados. Finalmente, uma boa comunicação, e essa nossa breve apresentação, faz parte desse nosso esforço de comunicação, trazendo, né, para o público como que está, né, como que a revista tem evoluído. Falando um pouco aqui sobre quantidade de publicações, a Soils and Rocks ela decidiu, a partir de 2020, aumentar a quantidade de artigos publicados por ano, como vocês estão vendo aí, né, nesse gráfico, e em 2026, o ano que já ainda está, né, em andamento, nós já temos a garantia de publicação de cerca de 80 artigos. Desses 80 previstos, aproximadamente um pouco mais de 60 já estão publicados. Então, essa é uma característica que revela que nós estamos com um fluxo de artigos muito bons e com a publicação adiantada em torno de 6 a 8 meses. As publicações da Soil Rocks, elas são organizadas em fascículos, mas o fluxo é contínuo. Quando o artigo é aceito, ele imediatamente vai para editoração, né, diagramação, e é publicado assim que fica pronto. Então, a gente não precisa aguardar a abertura de um fascículo para a publicação do artigo. Isso é muito importante, interessa muitos autores que o artigo não fique um tempo prolongado no chamado prelo, né? A Soil Rocks, ela incentiva a publicação, né, a divulgação de preprints. Ela também publica, quando solicitado, artigos ahead of print, que são os artigos que estão aceitos e que estão ainda no processo de diagramação. E a revista tem incentivado a proposição de fascículos temáticos com artigos de impacto e sempre publicações, né, de destaque, como as lectures tradicionais. Em termos de indexação, a Soil Rocks, ela tem indexação na Scopus, no Clarivate, na Web of Science, no Google Scholar, na CNKI, que é uma base de dados importante da China. Então, ela está presente nos principais indexadores. Isso significa que não apenas a Soil Rocks tem um fator de impacto quantificado. Significa também que quando um autor publica o seu artigo na Soil Rocks e faz a citação a outros artigos de outras revistas, essas citações estão sendo registradas e estão aparecendo no fator de impacto das outras revistas e nos fatores H dos autores. Então, é uma revista que está totalmente inserida na lógica, né, de indexação e rastreabilidade, né, das citações. Falando em como tem evoluído os índices da revista, primeiro, um motivo importante até dessa nossa apresentação hoje é celebrar a evolução em termos de qualis, né? A Soil Rocks, ela tem uma classificação que evoluiu ainda no triênio, na época era triênio, né, 2010 a 2012. Ela estava na categoria B2, na área de engenharias 1, e B1 na área de geografia. No quadriênio de 13 a 16, ela subiu levemente para B1, que é o terceiro de 8 estratos no sistema daquela época, que tinha A1, A2, e aí de B1 a B5. E aí no quadriênio seguinte, de 17 a 20, ela teve uma queda. Ela foi classificada na categoria B1, que era o quinto de 8 estratos. Na última avaliação, que foi divulgada recentemente, da CAPES, que diz respeito a como foram os parâmetros da revista entre os anos de 21 e 24, a revista foi classificada como A3, que é o terceiro extrato de 8, a terceira posição de 8 extratos, e isso nos deixou bastante felizes. Nessa última avaliação, o critério, né, que levou a revista a essa classificação é o percentil na Scopus e na Web of Science, a política de valorização de periódicos de associações científicas nacionais e também a de valorização de periódicos indexados na Cielo. Então, é importante dizer, a Soil Rocks, ela tem fator de impacto que está evoluindo na Scopus e na Web of Science, mas para obter a nota 3, ela também foi apoiada nas políticas de valorização, né, dos periódicos nacionais pela CAPES. Em termos de Scopus, o índice principal é o que é chamado Site Score, é o fator de impacto da Scopus. Esse gráfico mostra como que o nosso fator de impacto tem evoluído. Então, a gente teve uma estagnação com fator de impacto realmente baixo até 2022, mas a partir de 23 nós conseguimos fazer esse número crescer, né? E isso se deve a uma série de modificações nos procedimentos da revista, né, buscando aperfeiçoamentos que trouxeram aí esse resultado. Mas o que importa também não é só a evolução do fator de impacto, é a posição da revista dentro, quando você compara ela com as mesmas revistas da mesma categoria. No caso da Scopus, a categoria da Soil Rocks tem o título Engenharia Geotécnica e Engenharia de Geologia de Engenharia. Mostrando aqui a evolução recente nesses últimos 4 anos. A gente ainda não tem a divulgação final do 2025, mas a gente tem uma prévia. Em 22, a revista estava no 12º percentil, o que certamente era muito aquém do desejado. O percentil da revista é modesto ainda, mas ele tem subido bastante. Então, ele foi ao 22º, 34º, e agora para 2025, com o fator de impacto subindo, né? Lembrando, ele agora é previsto ser fechado em 2,1, a gente está com a expectativa de um percentil próximo de 40. Eu diria que internamente a nossa meta é atingir no curto prazo um percentil em torno de 50, que seria, né, já uma evolução bastante importante para a Soils and Rocks. Só conectando isso com Qualis, um percentil acima de 50 significa uma revista classificada como A4, independente dela ser nacional ou não. Então, uma revista que está no percentil 50, ela vira A3, uma nacional, porque ela está sendo valorizada por ser uma revista de uma associação nacional, né, ou por ser indexada no cielo, entre outros critérios. Falando de Web of Science, né, Clarivate, o fator de impacto ele é inferior ao da Scopus, mas também tem evoluído, mas com uma certa oscilação no índice JCR, como vocês estão vendo aí, de 22,05, 23, 1,1, e 24 a gente oscilou para baixo, e a gente tem tentado diagnosticar e entender por que essa oscilação para baixo, sendo que a gente teve uma melhoria na Scopus, e a gente tem alguns indicativos sobre os motivos. O índice JCI, que é o índice que tende a substituir o fator de impacto dentro da Web of Science, porque ele é um fator mais rigoroso, tem outros critérios, esse tem subido de uma maneira mais consistente. Então, ele atualmente está em 0,21, é bastante aquém ainda do que a gente deseja, mas a gente tem conseguido fazer ele subir. Agora eu vou só, para me encaminhar para terminar essa breve fala, queria só trazer algumas informações sobre como tem sido os procedimentos, né, da Soils and Rocks. Primeiro, em relação à submissão e processamento de artigos. Essa imagem aí à direita é o portal de entrada no nosso sistema de submissão, que é um sistema desenvolvido pela editora Q. Então, em termos de número de submissões, a gente tem recebido um aumento nesse número de submissões, o que significa que a revista está despertando mais interesse dos autores. De 24 para 25, por exemplo, a gente teve um aumento de 77% na quantidade de submissões. Isso também se reflete na quantidade de artigos publicados pela revista. Isso traz para a gente um grande desafio, porque uma quantidade grande de submissões significa muito mais trabalho em termos de conseguir pareceres de qualidade para os artigos, né, que vão nortear a decisão editorial sobre o aceite ou a rejeição do artigo. Mesmo com essas dificuldades em quantidade crescente de artigos, a gente tem conseguido manter um tempo de avaliação relativamente curto, quando comparado com outras revistas da nossa área. O tempo médio de avaliação, primeira rodada, em 25, por exemplo, ele foi de 89 dias. Esse é o período. Não é o ideal, o que a gente deseja é que seja mais curto, mas dentro de todo esse contexto de dificuldade de conseguir, né, o trabalho, né, voluntário dos nossos revisores, é o que nós temos conseguido. De maneira geral, ter uma primeira decisão assim, e aí uma segunda depois de um artigo revisado, e uma decisão final, e publicação, editoração, tudo fechando em 6 meses, a gente considera um prazo relativamente muito razoável, comparado com o que é típico dentre revistas semelhantes. É importante lembrar também, dentro dessas políticas da Soils and Rocks, que a Soils and Rocks, ela segue o modelo Diamond Open Access. O Diamond Open Access é aquele sistema em que todas as submissões são gratuitas, não tem taxa de publicação, e os artigos, mesmo assim, são Open Access, são disponíveis para leitura sem nenhuma cobrança para os leitores. E isso, claro, é graças ao fato de que a revista ela é economicamente viável, graças ao apoio da nossa associação, da BMS. Todos os artigos são publicados usando a licença CC-BY, significa que os autores retêm os direitos, o copyright sobre o seu trabalho. Todos os artigos, desde 2021, são publicados imediatamente após a aprovação e editoração, como eu já tinha citado. Isso é importante do ponto de vista de publicação ágil. E uma coisa muito importante nas nossas políticas e procedimentos é que nós temos um guia de autores, um template muito bem elaborado, de elevada qualidade, muito sintético e objetivo. Isso garante aos autores uma pouca dificuldade na elaboração dos seus artigos. Últimos comentários aqui, né, no meu penúltimo slide, compromisso que a gente tem, né, também dentro da política da revista com ciência aberta. Então, todos os procedimentos da revista são baseados em revisão rigorosa por pares, seguindo procedimentos íntegros em todo o processo de publicação. Os artigos nas Soils and Rocks, eles passam por verificação de similaridade, usando especificamente o software Plágios. O processo de revisão, ele é revisão à cega, mas nós temos duas opções, o single blind e o double blind, onde os revisores não sabem quem são os autores dos seus artigos. Então, existe a opção do double blind, apesar dela ser pouco adotada pelos autores. No mínimo, o padrão da revista é exigir, no mínimo, 2 pareceres para poder fazer uma decisão sobre os artigos. Conflito de interesse, ele tem que ser declarado nos artigos. A revista incentiva o depósito dos dados gerados, idealmente, já desde o início, quando o artigo é submetido, de forma que os revisores possam examinar esses dados, né? Então, isso é muito importante dentro de ciência aberta, né, de integridade em publicação. Nesses tempos modernos aqui, a questão de IA também tem despertado muita atenção, e nós estamos exigindo que os artigos declarem se IA tiver sido usada no desenvolvimento do artigo. Não é proibido, mas tem que ser declarado, né? E, claro, o autor é o autor do trabalho, a IA ela é só um auxílio, quando ela é usada. E, finalmente, observar que a revista também tem uma preocupação com questões de gênero, e segue as diretrizes da SAGE de equidade de gênero e sexo em pesquisa. É um grande desafio que nós temos, mas nós temos tentado ter uma representatividade mais equânime possível, dentro do possível. Então, vou fechar aqui a minha fala, agradecendo à BMS, à SPG, né, nossas associações que dão o suporte para a revista, a todo o corpo editorial, aos autores e aos revisores, né, que realizam um trabalho voluntário, né, e muito dedicado. Obrigado. Devolvo a palavra para a Bernadette e o professor Renato.
Boa noite a todos, a todas. É um prazer estar aqui. Queria inicialmente e rapidamente agradecer a BMS e a SPG pela oportunidade e ao próprio professor Poulos, né, pela disponibilidade. E vou passar a minha introdução e a apresentação do professor Poulos ao inglês para que ele possa entender o que a gente está comunicando. So, I would like to start expressing my sincere appreciation to Professor Poulos for once again making himself available to deliver a high-level presentation to our society. One among the many valuable contributions he has so generously provided over the last years. Professor Poulos is a long-standing and esteemed friend of our soil mechanics community, maintaining strong and enduring ties with our country. These include his involvement in the design and consultancy of complex foundation systems for tall buildings, as well as his continued engagement with our academic institutions. In particular, he has hosted several postdoctoral researches in Australia, thereby fostering meaningful academic exchange and collaboration. His legacy within our community is indisputable. Over the years, he has built lasting professional relationships and friendships with many members of our society. Moreover, his publications and technical contributions are widely recognized and extensively adopted in foundation engineering courses across our country. Although his professional record is extensive and distinguished, I will present only a brief and concise overview of his main achievements. Okay, let's move to his bio. Professor Harry Poulos is currently a senior consultant with Tetra Tech Coffey in Sydney, Australia, and is also an emeritus professor at the University of Sydney. He has undertaken research into the analysis and design of biofoundations for onshore and offshore applications, and in recent years for high-rise buildings. He has been involved in a large number of major projects in Australia and overseas, including the Egnatia Odos Highway project in Greece, the Burj Khalifa Tower in Dubai, the Dubai Tower in Doha, Qatar, and the Crown Tower in Sydney. In 2010, he has elected a distinguished member of the American Society of Civil Engineers. In 2014, he was elected as a foreign member of the U.S. National Academy of Engineering. And in 2017, he received the Outstanding Projects and Leaders OPAL Award for Design from the American Society of Civil Engineers. He was also awarded the 2020 Peter Nicol Russell Medal by Engineers Australia for his lifetime achievements in engineering. And in 2023, the inaugural ISSMGA Lifetime Achievement Award. So it's a great honor to have Professor Poulos with us today. Again, I thank him for his time and for his willingness to give us this presentation. And in case anyone has any question, please write it in English, in Portuguese in our chat, and I will for sure make note of any questions that have been made. And maybe, hopefully, we will have some time in the end to answer some of them. Okay, so we are ready to start the presentation. And please, Professor Poulos, start whenever you want. The floor is yours.
Those of you sustainable foundations for tall structures. And I will talk firstly about what is sustainability. Then I'll say something briefly about foundation systems are oriented towards sustainability. I'll say something briefly about the process of design cost savings because of the focus on sustainability. And I'm going to finish up with that of energy piles. First, sustainability meets present, maximizing the ability of future generations to meet their own needs. Another one is using methods, systems, and materials that won't deplete resources or harm natural cycles. But basically, putting it in simple words, sustainability is the ability of a system to retain its functions over time. And in order to try and achieve and importantly, the environmental impacts. Now, This diagram shows very roughly the process of geotechnical design, which starts with goes through a characterization and construction, and we finish up with the product. But now in recent years, we have added this extra consideration, which is really part of the design and the construction, the assessment of sustainability. And that's what
Professor
I'm going to
Poulos,
try.
I'm
Yes.
sorry to interrupt you, but we are having some technical difficulties. Your sound is, I don't know if it's a connection problem or if it's feedback.
What I'll do, Renato, is I'm going to go then through a headpiece and microphone, which may be better.
Let's see.
Is that an improvement?
The sound has the same artifact, so it means it's not feedback. It's a connection problem. I wonder if we could try reconnecting, because it's really difficult to understand what you're saying. And the sound was working just fine just before, right? So it's probably some.
Yeah. It could be a connection. I'm going to try one other thing, connecting directly. I'm trying another.
Okay, now it's muted.
Sorry, I didn't look at it. So what?
Yeah. Now, based on your camera, I see that it's a lag. It's a slow internet for some reason. Because you are skipping some frames. So I wonder if we could try reconnecting, just to see if it fixes.
Right. Let me see if I can do that. This probably requires technology.
Your sound is
I'll
better
do my
now.
best.
Yeah, I don't know what you did, but it's good now.
Does that? Do you want me to sort of reconnect on the?
What do you guys think, Renato? Can you hear Professor Poulos well now?
I think it's better now. I don't know what he did. I thought the problem was in my computer, but I noticed that other. Yeah, now it's better.
Now it's better. I think it's normal now. I think we can continue.
Unfortunately, Professor Poulos, we will have to restart because since the beginning the sound was lagging and crashing. We couldn't understand anything.
We waited a little bit to see if it improved, but it didn't. So, yeah. But I think it's good now.
Perhaps if you turn off your camera, it would improve. But let's start with the camera on. Let's see how it goes.
Can you say something again so we can check?
Okay. Is this in your control?
Sound is good. Sound is good. Sound is good. We can resume, I think.
Can you hear me better now?
Yes, we can. Yeah. So Juan, can we
Very good.
resume?
All right. Well, I apologize. Obviously, these technical issues do tend to create problems. Let us resume then. There was an interesting thesis by a gentleman called Saravanan a few years ago that looked at the impacts of pile construction in relation to the emission of carbon dioxide. And he took an example of 24 board piles, 13 meters long and 0.3 meters diameter, so quite small piles.
but he worked out that the construction of these board piles caused an emission of 21.2 tons of CO2. So even with a relatively small foundation system, and the piles are relatively small, there was a substantial emission of carbon dioxide in constructing and installing these piles. And he went on to, I won't dwell on these, but there are some guidelines in terms of the impacts of diaphragm wall construction, showing here for a 10-meter deep basement wall how much carbon dioxide is involved for wall thicknesses of 800, 1,000, and 1,500 millimeters. And basically, he worked out that for each cubic meter of concrete that we could save, we saved 0.46 tons of carbon dioxide. And importantly, for each ton of reinforcing steel, we saved 1.77 tons of carbon dioxide. So in these days, when we're trying to reduce environmental impacts and carbon development, saving these sorts of amounts of carbon in our foundation construction has to help. And what Saravanan concluded was that there were a number of practices in piling that could assist in sustainability. Adequate geotechnical investigation, efficient pile design, selecting the appropriate pile type, using combined pile draft foundations, using sustainable materials, testing of piles, and also the multi-use of piles, using them not only for carrying loads, but also for generating energy. And so some of the practical steps then towards sustainability: we need to minimize the use of concrete, construction time. Importantly, we need to take a more modern approach to design and focus on settlement-based design rather than capacity, because in many of the high-rise projects that I've been involved with, the governing factor in design is not really capacity, but settlement and differential settlement. Another thing we can do is to try and locate piles in the foundation system in the optimum location. So we try and concentrate piles below heavily loaded areas and have less or shorter or even no piles below more lightly loaded areas. And what that helps to do is to reduce the requirements for raft thickness, and that of course means less concrete, less reinforcing steel. We can also explore the potential of piles for energy generation, and importantly, and something that is being done in many urban areas these days, we can reuse foundations either on an existing building by making it taller and assessing whether or not the existing foundation system is adequate, or increasing the foundation system using the existing piles as the basis for doing that. So some of the ingredients then for economic foundations: we need the right concept, we need the right design criteria and methods, we need the right data and design parameters, we need to have quality construction, we need to do foundation element testing, which generally is pile testing, and importantly, and what is not done really even today adequately, is performance monitoring, because we need to be able to verify that our design processes are not dangerous or they're not over conservative. The foundation systems that we usually deal with are one of these three: raft foundations or mat foundations, fully piled foundations, and pile draft systems, where almost inevitably the basement slab or raft that we have is actually used as a load-bearing and settlement-reducing element, and that can lead to significant economy. Now, there was some interesting foresights on piles and pile rafts that go way back to 1957 with the tests that Whittaker did in the UK. And each of these diagrams shows and these are small model rafts, square rafts, 50 millimeters and 75 millimeters in size. The vertical axis shows the settlement as a percentage of breadth, and the horizontal axis shows the number of piles. And the important thing that we see from these tests, and it is important from a practical viewpoint, is once you get beyond a certain number of piles, in the case of the top diagram, that's 3 squared or 9 piles, and in the case of the raft in the bottom, some 16 or so piles. Once you reach a certain number of piles, the foundation system actually acts as a block, and increasing the number of piles has very little effect in influencing the foundation performance. So what that means is that if we put in a whole lot of piles, we're really wasting money, we're wasting resources, and we're not being sustainable. Now, pile rafts can be used in a number of circumstances. They are not a universal solution, but they are often a good solution. And they're useful where the raft can provide a reasonable amount of stiffness and load capacity. So, for example, if you have relatively stiff clay profiles, as they have in Frankfurt in Germany, or relatively dense sands, and also where soil movements due to external causes, such as groundwater withdrawal, settlements due to that occur. So if you have these circumstances, piled rafts may well be a useful option to pursue. The foundation process itself, a key aspect is site characterization. We need to understand the geology, we need to define the stratigraphy, we need to quantify the relevant geotechnical parameters. And we do that generally in terms of in situ testing, laboratory testing, and load testing. And I have a note here that in recent years, there's been a tendency to include in our in situ investigations measurements of shear wave velocity with depth. And the beauty of this is that shear wave velocity is actually a direct measure of the stiffness of the ground. And so it provides us with a basis for doing better settlement estimates than we had in previous years. So I'm a great fan of shear wave velocity measurements, and I always specify that we need to do tests that will try and define the variation of shear wave velocity with depth. The design issues, which I'm not going to go on in detail, but just to list them, obviously ultimate capacity that has to be satisfied, settlement and differential settlement and tilt, the response of the foundation to lateral loads and moments, the dynamic behavior, the earthquake response, and then from a structural viewpoint, obviously we have to have the foundation elements being designed to be structurally strong and adequate, and importantly, durability is also an issue that, particularly with many of the tall buildings, we expect that they will have a life of 40 or 50 years or more, and so durability becomes an important issue. Now, normally when we do this, we do 2 or 3 stages of design. We have a simple preliminary design procedure where we estimate the ultimate capacity, the settlement, the differential settlement. We also look at local design, the requirements for the raft and the piles carrying the column loads under the raft. And we make use of a very simple theory using Randolph's expressions to give us an idea of the load sharing between the raft and the piles. And what we can do with this, and it's we use simple hand calculations or computer methods. I use a program called MathCAD to do this, but it's very quick. And what we can do is we can look at the effect of the number of piles we have below a particular raft and see how the capacity and the settlement varies with increasing numbers of piles. And what we can do is we can construct a trilinear load settlement curve where there are three portions. The first from the origin to the point A is where the whole system is behaving more or less elastically. The second section from A to B is where the piles have been fully mobilized, so they're still carrying load, but now any additional load is carried by the raft. And then we have the third stage where we reach the ultimate capacity. And in general, we want to be somewhere round about this area here, where we're making good use of the piles and getting them quite highly loaded, but we satisfy both capacity and settlement criteria. And these little diagrams, the first one on the left is the ultimate capacity versus number of piles for a particular case. And what you can see, as you would expect, is that with no piles, we have the raft providing all the capacity. As we add piles, the capacity increases, but once we get to about 23 piles, there is no further increase in capacity because now the foundation system acts as a block. And in the same way, in the right-hand diagram, which shows settlement on the vertical axis versus the number of piles, as we increase the number of piles, the settlement reduces from the raft-only value of nearly 70 millimeters. And once we get to about 20 piles, we have a settlement around about 25 millimeters. Going beyond that, however, has no additional benefit in settlement. So you can see that by doing this sort of simple calculation, we can home in on what may be a sustainable and optimum design. And then, of course, once we've got that, we need to do a detailed design and make sure that we have all the details correct. So we need an analysis which can take account of interaction between the piles and the raft. We need to be able to consider practical soil profiles, not super simple ones. We need to allow for non-linear behavior of the soil, the raft, and the soil in the pile system. We need to be able to cope with non-uniform loadings. And ideally, we need to be able to consider different pile types and different sizes at different locations below the raft. And generally, these days, we have powerful finite element and finite difference methods. Two-dimensional analyses used to be used, but now it's quite common for fully three-dimensional analyses to be used, such as FLAC 3D, or in finite elements, Plaxis 3D, or the program RS3 from Rock Science. All of these enable us to do a detailed design and trying to refine the original simple design that we got from stage one. I want to now briefly describe three cases where we managed to use some sort of analysis and design approaches to reduce the piling requirements. The first of these is the Emirates Twin Towers in Dubai, for which we did the foundation design. And here they are in construction and finished. And one of the key issues here was that we had a series of pile load tests on single piles. We also did what Lamb would call a Class A prediction, which is shown by the dashed lines in this graph. And then we had a number of pile load tests, and the full lines show the actual load settlement behavior. And from these tests, we found that we were somewhat conservative with our prediction of capacity. The piles performed rather better. They settled a little bit less than we predicted, but not much. But importantly, when we put all the results together, this plot shows the ultimate skin friction that was measured from the instrumented pile load test versus depth. You can see that there's quite a variation of the tests, but importantly, I've shown here what used to be the design practice in Dubai in projects prior to the Emirates, and they restricted their skin friction to 100 kilopascals. What we found was that we could actually use, particularly deeper down, skin friction values which were 2 or more times larger than that previous design practice. And so the piles were less in number and shorter than if we'd designed on a conventional basis. The foundation performance was actually a lot better than we predicted. And though the term sustainability was not in use in the late 1990s when this project was undertaken, the design contributed to sustainability because of the methods of pile design, advanced laboratory testing and verification via pile load tests, which led to the use of less concrete and less reinforcing steel. The second case I want to describe, and it's not one of mine, but it's a case coming out of Italy by Mandolini and his colleagues. And this involved an examination of twin towers in Naples, which had been designed as fully piled foundations with no allowance for the raft. And you can see the buildings here, and in plan, a large number of piles. In fact, a total of 637 piles in this foundation system, length 20 meters and diameter 0.6 meters. Now, what Mandolini did was he looked at calculating what the settlement of this foundation system would be. There were, fortunately, measurements of settlement. And so what he found was that in this diagram there, this is the distance across the slab, the foundation slab, and this is settlement. He was able to get a very good match between what he calculated for the pile draft and what was measured. And this other diagram simply shows what the settlement would be if you used a raft without piles. Now, importantly then, what Mandolini and his colleagues did was they said there seem to be too many piles in here because they haven't taken account of the raft, and there's probably too many piles anyway. So they did an alternative calculation where they used, instead of 637, half of that, 318 piles. An allowance was made for the raft. And so there were only half the number of piles with the same raft. And what they found was, interestingly, that the calculated settlement with 318 piles was 33 millimeters compared with 30 millimeters for the 637 piles. So those extra 319 piles only led to a reduction in settlement of 3 millimeters. And also, in fact, the maximum differential settlement was improved and reduced by 10%. The total piling length actually used was 12.7 kilometers. The total length that could have been used was 6.3 kilometers. So there would have been very similar foundation behavior with 50% savings on the pilings. So therefore, greatly enhanced sustainability. The third case is one that, again, I was involved with, a high-rise tower on the Gold Coast in Queensland, Australia, called Teak, a 28-story residential building. The structural designer had designed a fully piled system to rock, and the piling contractor thought that it may be possible to actually reduce the piling requirements, so he engaged us to look at the feasibility of designing it as a pile draft because the structural engineer hadn't taken any account of the raft. And based on the results of that feasibility test, we came up with an alternative design for the contractor. Now here is a plan of the building. There's a board pile wall around here, 136 piles in the original design, and a slab 0.7 meters thick. Here is the ground profile. I won't spend too much time on this, but it was a situation where there was reasonable sand fairly close to the surface, so the ground conditions were in fact quite favorable for a pile draft. And so we went ahead and did a design, and in our feasibility study, we found that the raft foundation alone would have had a factor of safety of almost 10 for ultimate loading. So from a capacity viewpoint, we didn't need any piles, but the settlements would in fact have governed, because we estimated the settlements to be between 35 and 60 millimeters, so a maximum of about 60 millimeters if you had a raft only. But what we found was that the number of piles could be similar to what was used by the contractor, but importantly, we could use piles that were only 18 meters long, ending in a fairly dense layer, rather than 35 meters long going right down to rock. And this is just a little diagram of a program we used to look at the distribution of settlement. And you can see maximum settlements here. And in fact, the maximum settlement we got was 44 millimeters here, and a maximum differential settlement of 1 in 400, which satisfied the design criteria. So because of this re-evaluation of the foundation system, we had a reduction by 13 piles, so 10% piles less. Certainly the length was halved, and the total pile length was reduced by almost 2.8 kilometers, which resulted in a 52% savings in the foundation costs, and the settlement criteria were satisfied. Now, finally, in my last few slides, I just want to say a little bit about energy piles. And an energy pile is a pile that uses the thermal capacity of the ground around the pile to store heat. And this heat is pumped from the ground during winter and is replenished during summer. And you have pipes that circulate and with a heat transfer fluid, and it basically relies on a temperature gradient to transfer the temperature, the heat energy to electric energy. And it involves the use of a heat pump to increase the temperature if heating is required, or to decrease the temperature if cooling is required. And it works similar to a refrigerator or a central heating system. Now, there are a number of references on energy piles. Professor Heinz Brandl devoted his Rankin lecture in 2006 to this topic, and that's a very comprehensive paper. But there's also been interest in your country, in Brazil, from Professor Cunha and his colleagues, and indeed a whole issue of soils and rocks in 2022 was devoted to thermal applications in geotechnical engineering, including some papers devoted to energy piles. So this is a technology that is emerging and has emerged over the past 2 decades or so. These are the sorts of temperature profiles that we have in most countries. In winter, you have cold temperatures at the top, but the temperature increases with depth and becomes constant at some level. And in the summertime, of course, the temperatures are hotter near the surface, but decrease to a constant value down at some depth. And that depth depends on where you are on the planet. Obviously, the depth is less in Europe than it is in the tropics. But basically, you can make use of this temperature gradient to generate energy. And here's our normal deep foundation, which carries loads. And what we add to that is a series of geothermal loops for heating and cooling. So you finish up with an energy pile which has both reinforcement and these loops. And here is another diagram showing how these loops work. They have a structural function and also a thermal function for heating and cooling. And this is what they actually look like. Here's a normal pile with both the reinforcement and the heat loops. And here is a barrette with the same pair, the reinforcement and the heating loops. And here is basically a diagrammatic representation of energy piles. Here are the piles. You have a heat exchanger, and then you pump up the air, hot or cool, depending on what the requirements are. The performance of energy piles depends on many site-specific factors such as soil type, particularly thermal conductivity, groundwater depth and initial ground temperature. And the best conditions are in saturated sands and clays, especially if you have groundwater flow. And with the right ground conditions, you can get something like 25 watts per foot or 0.3 meters, so something like about 80 watts per meter thermal yield from an energy pile. Now, in the design of piles that are also energy piles, we have to be aware that not only does the pile have to withstand the structural loads shown on the left-hand side, but there are also thermally induced stresses in the piles. Now, if the ground is cooling, what this tends to do is to cause a tension or a reduction in the compression stresses in the upper part of the pile. So now your axial load distribution is rather less than it was, and in extreme cases, you may even get tensile stresses. If you have ground heating, then what happens is that in the upper part of the pile, you get additional compressive stresses. And so if you look at the axial load versus depth distributions, you get something that is actually similar to a negative friction situation where you get a maximum axial load or stress at some depth below the ground surface. So that needs to be checked in the actual design to make sure that the pile is structurally able to cope with those stresses. So if we summarize the advantages of energy piles, it uses the building substructure, so it's there already. There are significantly decreased costs in energy generation, and it doesn't require any additional land. The disadvantages are it may not, depending on the ground conditions, offer optimal conduction. It may require a modification of pile cap design and installation methods. You need possibly to have additional heat exchanger bores, and there isn't a great deal of experience in many countries, although in Europe and certainly in Austria, where Professor Brandl is from, it has been used now for quite a number of years, and I think in the UK as well. So it is something that is well worth considering in these days of increased energy costs. And there is an example that I was provided by Professor Katzenbach in Germany with the Frankfurt Main Tower, which shows that in this tower there were 223 piles, energy piles, that were installed. They provided 500 kilowatts of power, which was pretty much what they required for the operation of that building. So you can see that there are real examples of where the use of energy piles can be beneficial financially and sustainability-wise. So in conclusion then, I would say that sustainability and economy go hand in hand, that thorough ground investigation, rational design, and foundation pile testing contribute to both of these. If we use less piles, then we use less concrete and less reinforcement, and that reduces our carbon footprint. Pile drafts, in the right circumstances, have been found to be economic and effective foundation systems in many parts of the world, and we now have quite systematic design processes for these foundation systems. And in suitable circumstances, energy piles can significantly reduce heating and cooling costs and carbon emissions. And finally, I think this is a plea to those people that do these sorts of building developments. Monitoring, I think, is very important, not only to verify that our design and the foundation performance is in line with what we expect, but also to verify that we can appropriately design foundations that are sustainable as well as being functional. So that's the end of my talk, and thank you very much, and apologies for the problem that we have with sound. I hope the rest of the presentation was able to be heard.
Thank you very much, Professor Poulos. Was excellent. And I received here a lot of questions and interest from those who are participating online. So I try to group some of the questions so that it doesn't become, it doesn't have to ask for so many questions. So some few questions, but group it together in similar topics, okay? So the first one is regarding, standards and improvement of accuracy. So basically, it's right. And Professor Poulos, based on your experience, what shall be done to improve the accuracy of the prediction of a settlement-based design of a tall building in areas where the standards do not oblige contractors to carry out extensive or any in situ or lab testing? And I group it together with another question, which is, is it possible to design solely with SPT and pile-load tests? It's a great concern here in Brazil.
Of course. Well, look, let me say firstly that I would be very reluctant to be involved in any tall building foundation design which didn't specify a suitable suite of in situ testing and perhaps laboratory testing, but certainly in situ testing. I think in reality, the amount of laboratory testing we're doing these days has decreased, partly because of cost, partly because of time, partly because of the limited number of laboratories that can do high-level lab tests, but also because our ability to do detailed in situ testing, certainly with cones and with geophysical testing, we have got a lot better at doing that. Now, I think my answer to the first part of the question would be the only way that you can be confident of your settlement predictions is firstly to have a reliable method of prediction, and that means doing some sort of numerical analysis with the best possible parameters that you can get. And secondly, and most importantly, and it goes back to my last point before, we need to actually monitor the performance, particularly the settlement of the foundation system as you're building the building up. Because if there's a problem, you can catch it early. It's just like diagnosing cancer early. If you diagnose it early, you can fix it. If you wait too long, then it may not be operable, and you have bad outcomes. And it's the same thing with buildings. And we've had this, we've had both good and bad results with monitoring. We've had cases where the settlements have been a lot less than we predicted, but we knew that at least we had a very solid foundation. And there's been 3 or 4 cases I've been involved with where the foundation performance was in fact not what we expected. It was more settlement than we got. And what happens there is you have the opportunity to stop the construction, rethink, maybe enlarge or improve the foundation system so that you then can resume construction with a stronger, more able foundation system. Can you design solely with SPT? I know it's your practice in Brazil to do that. And my answer would be, I suppose modern people would say, no, the SPT is an outdated design tool. I mean, it was used 100 years ago, and you're still using it now. But I think in cases where you have sites that you understand and buildings that are similar to what you've done before and that perform satisfactorily, then that's fine. The problem with using SPT only is if you go outside the realms of your knowledge in terms of the stratigraphy and also in terms of the size of your building. So if you've had experience with a 10-story building on a site and now you want to build an 80-story building, I think using SPT only would be rather dangerous.
Okay. We have one of our drawbacks we have here is the question of monitoring. So I have a personal question for you regarding monitoring. Rarely we can get a building once finished to have a control of settlement or to check on the design that we have previously done. So how is your experience on that overseas? Because here in Brazil it's quite difficult to convince our client to have a monitoring at the end of the construction or during the construction itself, so that we can calibrate our model and our initial, let me say, predictions.
Yeah, this is a common problem, I'm afraid. Look, in places like Germany, it's actually mandated that tall buildings have to be monitored. And of course, that would be the ideal situation. But realistically, I think we have to try and convince the contractor and the client that what we're doing is really an insurance. I mean, he's paying a relatively small amount of money because, I mean, you can get away simply with level measurements. You don't have to do fancy instrumentation, although it is available. But you can do that sort of monitoring at relatively low cost. And this gives you the ability to both check on how the building is performing, and if it needs to stop, then it gives you an early warning sign. And I should say that I know that there is also, it's not something that I'm expert with, but our ability to do remote sensing and measurement of settlements from satellites and so on, and drones and these airborne devices is increasing significantly. I know there's now a lot of people monitor the stability of slopes and the movement of slopes with these sorts of devices. And so I think in future years, that will be an added incentive with relatively small costs. If the client is reluctant to monitor after construction is complete, that's unfortunate, but it's not fatal. I think the important issue is really monitoring during construction, because that's when you can find out if there's a problem.
Okay. I have also another question, which was grouped from 2 or 3 questions in the same subject, which is the subject of soil structure interaction. So I'm trying to give you my general assemblage, this question. Okay.
Yes.
For tall buildings, is it essential to have soil structure interaction to overcome unavoidable load redistributions and possibly properly check for final displacements and individual load capacities of the pile groups? And continue, at what extent, more or less, number of floors or size of the building would you imagine this interaction should really be compulsory?
Okay, some interesting questions there. Let me tell you what I do if I'm involved in a project these days. We tend to interact with the structural designer. And the first stage is that the structural designer gives us a set of loads from his structure which have to be resisted by the foundation. And they are generally based on the assumption of a rigid support system, okay? So he gives us these, we put these into our analysis, and this is at the detailed design stage, and we then work out how each pile performs, because it won't be rigid. Obviously, it will settle depending on the grouping and depending on the size and number of piles. We then go back and say to the structural engineer, here are our calculated stiffnesses. They're not rigid, but here are the stiffnesses for each of the piles in the system. He then recalculates his structural loads based on those stiffnesses, gives us those loads back, and we keep doing this, and it usually takes 2 or 3 cycles only, and we get a compatibility between the loads and the stiffnesses of the piles. Now, I should also say that in recent years, the software developers, there are 2 or 3 programs now which are able to cater for a complete single analysis of the structure and the foundation system, so that you can simulate the installation of the foundations, and that includes generally the initial excavation for the basement slab, installation of the piles, and then the construction of the structure. So that in itself is then obviously taking soil structure interaction into account. Now, the other part of that question was how many floors up before it's really important. I think, interestingly, as you get higher and higher, the higher parts of the structure are not influenced by soil structure interaction. It's probably the lowest 8 to 10 floors maximum that really are affected. The rest of the structure is basically unaffected. And it goes back to a very simple principle in mechanics, St. Venant's principle. The further away you are from something, the less effect it has. And so the further away the structure is from the foundation, the less effect the foundation has on the structure.
Okay.
Renato, Professor Poulos, there's some questions about energy piles. Trying to summarize them here. Specifically about the experience in terms of the design of energy piles in Australia. And I think that's really interesting for Brazilians, given the similarities in terms of climate, right? If you compare that with South Brazil, Southeast Brazil. So could you talk a little bit about the current experience in terms of what is the current design practice, and also another thing, just to combine here the questions, how is the different players involved, because this involves people outside of typical foundation design, right? How are they interacting?
Look, I'm not the best person to answer that. I can tell you, though, that there has been some research done in Victoria at Monash University and Melbourne University on the use of energy piles. They have been found to be feasible to use, but I'm not aware, to be honest with you, of any real practical applications, certainly not for tall buildings. They may have tried to do it with smaller buildings, and I think there's 1 or 2 cases I've heard of, but I don't know details of, where they have used energy piles. But this is still an emerging technology here, and I think one of the problems, and you're probably facing the same thing, is that there is a lack of local experience. And as you also indicate, that the knowledge base that is required goes beyond what most geotechnical engineers are comfortable with. But having said that, look, I mean, geotechnical engineering has evolved over the years. We knew very little 50 or 60 years ago. We knew very little about chemistry in soils, and now it's the basis of geo-environmental engineering. So I'm sure with a little bit of practice and experience that we will be more capable of doing energy piles. And I think there are, I guess it also depends on whether you've got contractors that have the capabilities of actually putting these loops into piles. So there's a lot of factors involved here. I'm sorry I can't be more specific, but it is certainly, as in your country, it's engaged interest in our country, but I don't think it's progressed too far beyond the research stage.
Renato, there's some more questions. Did you see? Did you understand the question by Fernando? You're muted. Yep.
We have a very quick question and then a final question, which I have grouped here. One of our participants have asked what is the name of these two softwares you have mentioned for soil structure interaction?
Right. I'm not fully aware of all the software. I know that on a Middle East project that I was involved with, the structural designers were using a program called Strand 7, STRAND 7, which, I mean, it started off as a structural program, but they've extended it to the foundation system. I think there's also a program called MIDAS that comes out of the UK or Europe that is capable of doing that. And in principle, although I don't think I'd want to do it, in principle, Plaxis 3D, because it enables you to, obviously, it's designed to model a foundation system. You can also have structural elements, so you should, in principle, be able to do it, although I don't know of anybody that's actually ever used Plaxis for that purpose, simply because it may not have the refinement in the structural design elements of the program that are required.
Okay, and a final question is also a group of questions with the same topic. It's related to shear wave measurements and deformation moduli.
Yes.
I'll make the questions, but they are all grouped together. Yes. Do you think that in situ measurements of shear wave velocity would be more adequate than moduli from laboratory tests? Would that eventually substitute laboratory or back-analyzed moduli from pile load tests? And finally, could you recommend, instead of that, correlations of the deformation moduli of the near surface soil layers to be practically used in design? How is your experience on that? So it's the final question.
Okay. Well, look, firstly, will in situ measurements of shear wave velocity then supersede laboratory measurements? Possibly they may, simply because in the laboratory, you're taking a sample that's already disturbed in some way, even though, you know, I mean, it's been disturbed because it's been taken out of its natural stress environment and put into a laboratory. We now have to try and impose in situ stresses on that soil, and we're not certain of those, and then we load it and measure our modulus. Now, the beauty of shear wave velocity measurements is that you are measuring not a small sample, but you are measuring a fairly large volume of soil. And because you're doing that, you are actually, any geological imperfections or cracks or whatever, soft layers in the soil, their effect will be picked up in the shear wave velocity measurement. And so it really gives you a much better idea of how the soil responds in situ. Okay? In terms of the design and correlations, will it replace back-figured pile load test data? No, I don't think so, because in the end, I mean, the pile load test data, if you interpret it, tells you how the pile behaves, and that's what you want to know. It applies the stress system that is relevant to your foundation pile. So I would always trust those sort of values if they're interpreted correctly. And you have to be very careful that you allow for things like initial stresses and so on, and locked-in stresses. In terms of correlations, I use correlations universally, certainly in the first instance. And near-surface correlations are not generally critical if you're dealing with vertical loads on deep piles, because most of the action tends to occur lower down. Where correlations near surface are important, where you have lateral loading, there's a major loading, because there you have near surface, you have probably unsaturated conditions, you have cyclic situations with temperature and the cracks and so on. There's all sorts of difficulties with near surface soils. So, I mean, inevitably we have correlations that we use to some extent based on experience that can be valuable as a yardstick. So if our correlation tells us that the modulus is 5 megapascals and we actually measure 500, then we start worrying whether our measurement is actually valid. But look, I think I'm a strong believer in using all the data that we can to get estimates of our parameter, and then trying to assign reliability, and I don't mean in a numerical sense, but what do we trust most and what does each test tell us in terms of the parameters that we choose.
Okay. Thank you very much, Professor Poulos. Just to finalize, we have in the chat many colleagues which have congratulated you on this talk. I will just mention briefly some of them. Dr. Luiz Guilherme from São Paulo, Professor Fernando Danziger from Rio, Professor Fernando Monteiro from Unicamp, Professor Leandro Neves from Minas, Professor Wilson Conciani, retired from our region here, and many others have congratulated you. And I honestly, personally, would like to give my heartfelt congratulations and thanks for this participation. I know that you are a very busy person and you are retired already, so we are kind of abusing with you, but thank you very much. Really, thank you very much. And I hope to see you, in some near event, perhaps, who knows, over here in our next national event in Brasilia. It's going to be in Brasilia, Cobransec, next September this year, or perhaps in the future, who knows, in Europe or in Australia, of course, without any stopover through the Middle East. We will avoid the Middle East for the time being.
Another way. Yeah. Thank you very much, Renato, and thank you everybody for arranging this and for taking the time out to listen. I'm very appreciative. Thank you.
And I will finalize asking the ABMS representative, Professor Bernadette, to wrap up our event. Please, Bernadette, come over.
Pois não. Bom, em nome da BMS, eu gostaria de agradecer ao professor Poulos pela brilhante palestra, temas abordados muito interessantes aqui para a nossa realidade, né? Nós estamos começando a mexer com esses assuntos, né? Aos moderadores também, né? O professor Renato Cunha e ao professor Gilson, Gitirana, agradeço muito também a organização do evento, né? A ideia de ter chamado o professor Poulos para nos brindar com essa excelente palestra. A todos também que nos prestigiaram aqui com a sua audiência, né? Agradecemos a todos vocês e desejamos, então, um bom final de noite para todos. Até a próxima, então.
Ok. Bye, bye.